Alright, welcome back. This is a review that's going to cover two sections. One of them is the ratio test, and then the other one is finding the finding the radius of convergence and the interval of convergence. So firstly, I'm going to start with this definition that the limit as n approaches infinity of a sub n plus 1 over a sub n. This is the ratio test. If the ratio test is, let's set this equal to some variable z. If z turns out to be 1 exactly, then the test is inconclusive and it doesn't actually help us. We need to try a different method if it equals 1. If the ratio test results in a number larger than 1, then the series diverges. And if the ratio test results in a number less than 1, then it converges. So we're going to use that knowledge. And if you think about it intuitively, it kind of makes sense, because this is going to be your last term, your second to last term, and this is your very last term. So if the number is larger than 1, that means that your last term is larger than your second to last term. That means that your series is growing larger with each term. But if it's less than 1, then that means that this bottom, the second to last term, is larger than this last term, and that means that it's trailing off to a specific point, it's converging. But if they're equal, then can't really tell you. Cannot tell you. So this review has a simple, simple first question is broken into 3 parts, and they just give you values of a ratio test, and you need to evaluate if they are convergent, divergent, or inconclusive. So these are our values of the ratio test. So this one's larger than 1, so it's going to diverge. This one is less than 1, so it's going to converge. This one is equal to 1, so it's inconclusive. And this one is less than 1, so it converges. Hopefully that makes sense. So now we're going to work on the second one. Excuse me. I just need to rearrange my workspace here. Alright. So this is n plus 9 over n factorial. We're going to evaluate with the ratio test. So let's have the limit as n approaches infinity of the absolute value of n plus 1, right? We're subbing in n plus 1 for this n. And we're subbing in an n plus 1 for this factorial. So what is n factorial? Well, that's n times n minus 1 times n minus 2 times n minus 3 times ... all the way to n minus r. So we can think of n plus 1 factorial as n plus 1 times this section, right? And that is equal to n factorial. So this is actually just n plus 1 times n factorial. And then we're going to divide by a sub n. But since it is a fraction, I'm just going to multiply by the reciprocal. So I'm going to multiply by n factorial over n plus 9. So this is equal to n plus 10 over n plus 1 times n plus 9. And you're supposed to write a limit here, running out of room. So we can see here by the highest degree that n plus 10 is going to be over n squared plus 10n plus 9. And by this highest degree formula, this denominator is going to grow exponentially larger, and this numerator will never catch up with it, so it is going to converge to 0. Next, we're going to look at the last one for this first page of review, then we'll move over to the second one. Oh, my keyboard keys just fell off. There we go. So this is our second one, the series 5n plus 3 times 5 to the n plus 2, all over 8 to the n. So let's take the limit as n approaches infinity of a sub n plus 1, a sub n. So I'm going to do 5 n plus 1 plus 3, 5 n plus 1 plus 2, all over 8 n plus 1. I'm going to multiply by the reciprocal, which is 8 to the n, over 5n plus 3 times 5n plus 2. So that is going to equal, once we simplify here, this is 5n plus 5 plus 3, so that's 5n plus 8. This section and this section are going to cancel out, and we're left with a remainder of 1, right? So it's just going to be 5 to the 1, which is just 5. And the same thing is going to happen with the 8s, where these are going to cancel out, and we're just going to be left with a positive 1 on the bottom. That's 8 to the 1. And then we still have this 5n plus 3. So if we take the limit of this equation, we can see that the coefficients are the same here. So this is going to be equal to 1. So we can just completely write that off. We can evaluate as if that did not exist, right? Because this is going to be 5n plus 8 over 5n plus 3. And this is going to be equal to 1. But we're multiplying that by 5 over 8. And 1 times 5 over 8 is 5 over 8. So this series converges to 5 over 8. Feel free to try the rest of these if you have access to the review document. They're pretty similar. They don't want you to find an exact value. They just want to know if it's convergent or divergent. So next we're going to move to 8.5 with the radius of convergence and the open interval of convergence. So let's do this one first. Oops. This is 3x to the n over n factorial. So we're going to apply the ratio test again. 3x to the n plus 1 all over, I'm going to write this n plus 1 factorial as how we defined it before. I'm going to multiply by the reciprocal. So simplifying this, we get the limit as n approaches infinity of the absolute value of 3x to the 1 all over n plus 1. So as n approaches infinity, well, we only have an n term in the bottom, so this is going to equal 0. And since this equals 0, we have no x term left. So our radius of convergence, well, our interval of convergence is going to be any x value this series will go to 0. And the radius of convergence will be infinity. Let's look at another example here. So find the largest open interval of convergence and the radius of convergence for this series. Let's apply the ratio test again. -1 to the n plus 1, x to the n plus 1, n plus 7 plus 1 is n plus 8. And then I'm going to multiply by the reciprocal. So simplifying this gives us a -1 on top. It's in an absolute sign, so it's just going to be 1 by the end of it. So that's not really important. This is just x to the 1. Then we have n plus 7 over n plus 8. So as n approaches infinity, these constants being added are going to be negligible, and then we're just left with n over n, and they have the same coefficient, so that's going to be equal to 1. If you want to write out that step, feel free. It's going to be n plus 7 over n plus 8 times your x over 1. And I guess there's a -1, but does not matter because it's in an absolute value. So you notice this is 1, this is multiplied by x, so the limit of this is going to be equal to x. Now when you're finding the radius of convergence and the interval, is this less than or equal? I'm unfamiliar. But this is what you're going to be evaluating, and this is going to be what you plug in. So right now it's already solved for x, so our interval is -1 to 1, and our radius is 1. Let's say this was like x over 3. Well, now you'd need to solve for x, so you'd multiply by 3 on both sides, and you'd get your radius to be, or your convergence, interval of convergence to be -3, 3, and your radius to be 3. So let's look at one more here. Whoops. All right, last one here. Find the largest open interval of convergence. So let's take the ratio test of this series. It's going to be x minus 1 to the n plus 1 all over, this is n plus 1 times 2 to the n plus 1. Then we're going to multiply by the reciprocal. Now we're going to simplify. And these terms are going to go just to x minus 1. This n does not cancel out, but this 2 does, right? We're going to be left with just a 2 on the bottom. So let's put the n up here, the n plus 1 here, and then just the 2 left on the bottom. So you can see we have the same degree, coefficient, everything with n's. So I'm just going to write that here. So this portion is going to be 1. And then we're multiplying it by x minus 1 over 2. So we can pretty much ignore this, right? It's just equal to 1. But now we need to set up our inequality with x minus 1 over 2. So let's multiply both sides by 2. And then let's add the 1 to solve for x. We have minus 1, x, 3. This means our interval of convergence is -1 to 3. And our radius is going to be equal to 2. Sorry, let me find a good example here. All right, so we're able to evaluate this because of this identity here. The absolute value of x minus 1 is less than 2. So our radius, our change in x values, must be 2 within this interval. All right, that is the end of this review, and thank you very much.